In this video, I will show you how to extract building quantities from 3D or building information models using the most basic manual method. To employ this method, having a basic 3D model of the relevant discipline is sufficient. This means you can work only with architectural or any other single discipline model. To extract quantities manually, you can use any of the numerous tools such as Autodesk Viewer, SolidBrief Anywhere, OpenIRC Viewer, and so on. And the great thing, most of these tools are free to use. Almost all of these tools enable viewing and measuring objects within the 3D environment, reducing reliance on potentially inaccurate 2D drawings. So let me show you how it works in Autodesk Viewer. Autodesk Viewer is a free browser 3D and building information model viewer, which works with numerous file formats, but the most commonly used are Revit, Navisworks, or IFC files. In this video, I'll show you the quantity extraction basics, but if you want to learn more about the Autodesk Viewer tool, you should check out my tutorial in the description below. When you have your model loaded in Autodesk Viewer, you can utilize any of the following 4 methods to extract quantities. So first one is manual counting. It is the same method that estimators use working with 2D drawings, but the biggest difference is that you are looking at the objects in 3D environment, which means you could be less likely to miss something. You can use the ability to rotate, section, or hide elements, and then simply count them. So in this example, I'm showing you a structural model. So the idea is that you are simply being able to count the different objects. And then if you want to access and better view these objects, you can use, for example, functions like section. So let's say I add a section from Z plane here, and you're able to better view the objects inside the building. You can also use the ability to hide objects. Say hide selected. You can also remove the section like this, and then you'll be able to see the wall's transparency in this case, and you could see inside that there are 2 beams here. So the second method is using the tape measure. So here you have the measure tool. So there are several principles you can use, either distance or angle. I'll show you how the distance works. So this tool is usually available in all the free viewers. And what you do is you just select a starting point. It will automatically try to snap edges or intersections, but you need to be careful because you're measuring the 3D environment to snap to the correct point. So here I did it, and I have the measurement of the beam here. So I can rotate it around, have the other dimensions of this beam, and then I already have the ability to calculate, for example, volume. So again, this is a manual method, but it's really easy to use. And again, you can improve the accuracy a lot. So the third method you can use is filtering objects. And when you open here the model browser, you can see the hierarchy of the objects here. So you have a structure where objects are grouped by different categories. So here you have walls, structural foundations, structural framing, floors, structural columns, and some generic models. So what you can do is you can simply hide the relevant objects by clicking, or you can even open subcategories here and try to filter out some objects by their types and so on. So this heavily relies on how the models have been made and if the objects have been structured correctly and named correctly, and only then this will properly work. But this allows you to quickly access separate objects and then use additional tools like the tape measure to measure them quickly. So to improve the visibility, you can also go to settings here under configuration and untick this, goes hidden objects, and then you'll be able to see only the objects you have selected like this. So as I said, there are different categories you can use. For example, here structural framing, and then try to filter out by the different types. But as you can see, it it heavily relies on how the models have been made. In this case, filtering further is quite difficult, and you can see that it has some single elements, but if you want the full truss, for example, it's not that easy. And the final method to use when manually counting objects in a model is to rely on the attributes or the parameters inside the object. So if you click any object in the building information model, you can access its properties, in this case right-clicking and pressing show properties. And here you have the different parameters or the attributes inside the object. And when I scroll down, for example, I would have attributes like area, volume, length. So this might be useful for you to calculate your quantities, and most likely this is correct, and you have the opening also not counted inside this area, but I would always recommend to double check these quantities just to be sure that the correct modeling principles have been used. So this again heavily relies on the way that objects have been made. So if I would click on this column here, I would find no dimensional quantities here at all. So it means that it has been made in such a way that you cannot extract quantities. It's also a question if you're working with exported models like the IFC format, you might be missing this information as well, or it might be not correct at all. But in looking at this column, I have very limited amount of information. There is a type name, but it's a name, it's given manually, so it could be wrong as well. So I should be double checking whether this information is correct before using it. So these are the 4 methods to use to manually extract quantities from 3D or building information models. Though these methods are time consuming to use, they can anyway give you a much better understanding of the building and of the object quantities if you would be using only the 2D drawings alone. So in the next video, I'll show you how to extract quantities using a semi-automatic method. Thank you.